So in this video, I'm going to show you how to use Maclaurin series expansion with compound functions. So here we have some standard Maclaurin series expansions, which are provided in the Edexcel A-Level formula booklet. And throughout the lesson, we'll be using different ones of these expressions. Okay, so we've been asked to write down the first four non-zero terms in the series expansion of sine of x squared in ascending powers of x. So you can see that we're going to use the sine x expansion. But to do this, we need to let x map on to x squared. So all we're going to do is substitute x squared in place of x for each of these. So we can say that the sine of x squared will be approximately equal to, because we're not looking at all the powers of x, just the first four non-zero terms, well, we have our x term, which is mapped onto x squared. We have x cubed, so that becomes minus x squared to the 3 over 3 factorial, plus x to the 5, so plus x squared to the 5 over 5 factorial. And to work out the next term, well, can you see that there's a pattern here? We've got x squared to the 1, and then to the 3, then to the 5. So this will be x squared to the 7. We have a positive, a negative, positive. So this will be negative. Then we've got 1 factorial, 3 factorial, 5. So 7 factorial. Okay? So now we can simplify each of these. We've got the x squared term minus, using the power rule, this becomes x to the 6. So minus x to the 6 over 3 factorial, which is 6. And then x to the 10 over 5 factorial, which is 120, minus x to the 14 over 7 factorial, which is 5040. So this is the first four non-zero terms of a Maclaurin expansion for sine of x squared. Okay? Let's move on to example 2. So in example 2, we've been asked to work out the first terms up to x to the 5 for the natural log of 1 minus 2x. So we're going to use this expansion here, but we need to let x map on now to a negative 2x. Can you see that this positive x has been replaced with negative 2x? So we have this approximately the x term, so that becomes negative 2x, minus this x squared becomes minus 2x all squared over 2. This x cubed becomes plus minus 2x cubed over 3. And then the next term will be minus 2x to the 4 over 4. And then we've got plus negative 2x to the 5 over 5. So now we can tidy this up. We've got our negative 2x at the start. And then negative 2 squared is 4, divided that by 2 is 2. So minus 2x squared. Negative 2 cubed is negative 8 divided by 3. So minus 8x cubed over 3. And then we've got negative 2 to the 4 is 16. Divided that by 4 is 4. So minus 4x to the 4. And then we get negative 2 to the 5, which is negative 32 of x to the 5 over 5. So this is the series expansion up to x to the 5 for the natural log of 1 minus 2x. Okay, so for part B, state the range of values for x for which this expansion is valid. So because it's a logarithm, we know that the x term minus 2x must be less than or equal to 1, but greater than negative 1. So to work out x, we need to divide both sides by -2. Will be where x is less than 1/2, but greater than or equal to -1/2. Okay, let's move on to question 3. Okay, so finally, in example 3, we've been asked to work out the Maclaurin series expansion for e to the minus x sine x, up to and including the x cubed term. Okay, so because we're looking at x cubed, this will narrow the number of combinations that we need. So if we look at e to the minus x, well, we'll replace this x with negative, so this becomes 1 minus x plus negative x squared over 2 factorial plus the negative x to the 3 over 3 factorial. And we can simplify this as 1 minus x. Negative x squared is x squared over 2. So plus x squared over 2. And then negative x cubed over 6. And if we look at the expansion for sine x, well, we're given this is x minus x to the 3 over 3 factorial, which is 6. I don't need to think about any of these because we're only looking for the x cubed term. Okay, so this becomes the product of these two expansions. So 1 minus x plus x squared over 2. I don't need to include this term because when it is multiplied by any of these, we get x to the 4 or above. So then it's multiplied by x minus x cubed over 6. So our first combination will be x times 1, so x, and then for 1 times negative x cubed over 6. The negative x times x gives us negative x squared, and negative x times this cube function will give us x to the 4, so we don't need to include that. And then finally, x squared over 2 times x. So that becomes x cubed over 2. And we can collect the like terms, so we get x minus x squared plus x cubed over 3. Okay, well, thank you very much for watching, and I hope you found that useful. You can download the full lesson and worksheet from our website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.